Hello everyone, welcome back. Welcome to Vision Technosub Private Limited. Today we are going to discuss about the topic called as topology. In the further videos, we have discussed about the introduction of NPLS, we have gone through the networking devices, we have discussed about the cable. Apart from all those things, this is the topic that we are going to discuss is very important in the perspective of architecture. The agenda of today's session is going to be what is topology, types of topology, and the explanation about the types of topology. In this whole session, you will be learning what is the architectural point of view of the networking segment. That is what it says. If I discuss after learning what the outcome is going to be, the outcome is you will be understand what is topology, why it is important, why it is used for, where is the place it is used for, and how the network forms. These are the few terms which will give you the explanation, which will give you the understanding how the topology plays a very vital role in forming our network, our cell phone tower, us, Bluetooth, file sharing, connection, how the things form. In all the way, all the term, our topology is important. So let's start our class without wasting time over the topic called as topology. Okay, over here, our first thing is topology. Our first thing is topology. Now, what is topology? What it is used for? Why topology? So if I give you the definition over here about the topology, so it is the structure of the network, which is how all the network components are going to connect with each other. This is what the topology says. Why? Why the structure components? Why the structure of the network? Why this thing? So in the many way, in the many term, the topology is referred as architecture. It is referred as structure, blueprint, frame, diagram. All the things are correct related to topology. What we say, all the things are correct. In this term, why this thing is important? Because in the further session, you all have gone through the term network establish the connectivity. The thing says the devices help us to establish the connection, the cable which is making the things connected, but how the thing is going to be connected. If I say I'm saying hello to you, then how I can say hello to you? There will be the procedure, there will be the way. Yes, I can give you the greet, I will say my name first, then I will say hello to you. I can't just appear in random and say hey, how are you? No, this is not the way. In this whole the term, the topology also plays the same way. How my devices is going to say hello to the another device, how my network is going to form with another network, how I'm going to connect with one network to the another network. That is what the topology says all. In this whole term, we are having the six type of topology. If I give you the types, six type of topology. First one is bus, second one is ring, third one is star, fourth one is tree, fifth one is mesh, and sixth one is hybrid. These are the types of topology that we have seen in over here, that the mention name you are having. These are known as the types of topology. In further, in the context of this type of the topology, if I start discussing about, so they are the one more term that in the most of the Google places, if you will search, you will find there are the two type of topology. First, they will define the physical, logical, then they will come up with this type of topology. What are the physical and logical? The physical we all know connected via wired, but what is logical? The logical they refer as a wireless. Logical they refer as a wireless. In the logical, we wireless format only one topology follows, that is mesh. There is a no topology called as a wireless or logical. The reason behind that, every wireless connection required the wired connection first. Every Wireless connection required the wireless connection. Sorry. Every wireless connection required the wired connection first. That is what it says. That is why the topology is important. I can see all over the worldwide, over all your worldwide, not only me and you, not only your cell phone network, your every single thing based on the wired connectivity, based on the wired connectivity. That is what it says over here. That is what the thing is over here. That is what we discuss in this topology. So basically, the topology gives us the architecture point of view. Architecture point of view, how the thing is going to form, how the thing is says, how the thing is called. I hope the definition of the topology and the types of the topology till over here is understood by everyone. Right? Now, let's further start with the explanation. What the explanation include about this six type of topology? Let's have the things. Explanation of topology. Which is the first topology we have? The first topology we have is our bus topology. Is our bus topology. Now, what the bus topology says? The bus topology says, let me write down the definition. Okay. Now over here the thing is the bus topology is designed in such a way that all the stations are connected through a single cable. All the connections, all the stations are connected through the single cable. Remember this point guys? The backbone cable is considered as a single lane through which message broadcast to all the stations. Each and every node are connected with each other through in a series. Through in a series. If I give you the visuals, if I give you the visuals, let me give you the visual over here. Just a second. This is what we got, right? Me, let me bring with the another thing. Yes, this is perfect. This is perfectly fitting over here. Over here. This is what the bus topology you have. Over here, what you are saying. Over here, what you are saying. There is a one cable which is moving, and with this cable, the everything is connected. With this set of the cable, everything is connected. This cable, I'm talking about this cable. I'm talking about this particular cable. This cable. I'm talking about this cable. This particular cable. This particular cable is known as a backbone cable. Why? The thing is कि bus topology rely on the single cable. Let's understand the bus topology in this way. We all travel via bus, right? We all travel. We all travel via train as well. So where the train goes on the different path or on the single path, it is having one track defined that we say a railway track. And with that, on that track only, the train runs. The train goes from one point to the another, from source to the destination, and in between the source to the destination it is having the different stations. So in that same context, in that same term, The nodes which is present over here in this topology, we call them stations. We call them station, the nodes. This one nodes, these nodes. What this nodes called as? What this nodes called as? This node called as stations. Stations, right? In this topology. In this topology, this nodes called as a stations, and is referred as this cable is referred as a backbone cable. A backbone cable. Backbone cable. Why? Why a backbone cable? Because the whole topology, the whole network connections is fixed over here. The main key point of this bus topology is that need to be keep in mind is that the whole topology, this whole bus topology will form by using only one cable. It cannot have the twice or thrice cable. No, the two or three or five or eight sets of the cable that we use, that is not going to happen over here. Only one cable over all the connections. Over all the connections. And how the connection format in the series. What the series? One, two, three, four, five. The how the picture says on. This is what the bus topology says. In this, in this bus topology, by using it, if I talk about its advantages, so advantages are low cost. Yes, the implementation is very low. You can implement it. There is no problem at all, right? We also know for the cost cutting statement, we don't want to spend a huge amount. That is what we are having the familiar design. Yes, this design is always familiar that we have seen. Okay, now moderate data speed. Now, what is the meaning of this statement called as a moderate data speed? The meaning of a statement about this, the moderate data speed, says not too fast, not too slow, just the minimum level of the speed, just the minimum level of the term, where my whole node can establish the connectivity and can do the task. Also, in this topology, the broadcast happen. Broadcast means here you are not having any kind of the intelligent device available. No any intelligent device. We are not having switch, we are not having hub, we are not having any kind of the router over here that will say ki yes, this place, this node is located over here, you have to go there. No, it will broadcast the message at every point. It will broadcast the message to everyone, whether the node number one is sending the message to the node number last, it will broadcast to the everyone. That is why it happens, because everything in the series, and the nature of the series is to broadcast. Nature of the series, you all have, like in the 8th or 7th class, we studied about the series combination, we studied about the parallel combination where we form the electrical circuit. Okay, in this our electrical circuit, what we see, we have the one number of the connections where if the one goes down, not the another one is working. In the same way, if the one goes down, the another one will not work. It will broadcast the segment. It will broadcast with everywhere, right? It will broadcast the message in this bus topology. In that same way, if you travel with the metro, if you travel with the metro, you have seen whether you know the person, whether you don't know the person, you can say this thing where this person boarded. Boarded means from at which station that person entered into the metro, right? Suppose I'm traveling, I'm going from Noida sector 50 to the 16. I boarded at 50. You know me or you don't know me, by seeing the statement, by seeing the station, by seeing my face, you can say कि this person boarded at uh, sector 50. So that is the broadcasting. Without saying anything, that broadcasts the message. That broadcast with everyone. In that way, the person is moving out from the metro. You can also say that that person boarded at this location. The person goes out at this station. That is what happens with one, as the things are traveling from at certain path. The path is defined. In that whole path, the data will form. In that only path, the connection will be goes, and that path is known as a backbone path, the single lane cable. That backbone cable why this thing is called as. That is what the thing says. If I talk about a disadvantage, so disadvantage is over here. Disadvantages that is we are having is difficult in troubleshooting. Yes, difficult in troubleshooting. What is the meaning of troubleshooting? The meaning of troubleshooting is to remove the problem, is to solving the problem, is to giving the cure of the problem, means solution of a problem that arises. So the difficult in troubleshooting that refers कि if any point encounter with the problem, it will shut down the whole network. If any point, any set of the problem occur, it will shut down the whole network. When the whole network is shut down, then what do you think that it is possible for us to filter out? It's possible us to identify where the problem is? No, that is not going to be defined. That is why it says difficult in troubleshooting. After that, we are having single interface. We are having the single interface. What does this single interface refers? What is the meaning of this single interface? The meaning of this single interface is that you are having only one interface where all the connection is going to form, where everything is going to be, not the another one. Means you are having only one cable that is known as the backbone cable. What the input, what the output, what the thing is going to be happen, that is going to be happen on that particular cable only. And if any kind of the problem rises, then you will be ran towards the network failover due to the single interface. That is also a disadvantage. We should have the multiple interface. If one goes down, I am having the backup. Here we are having only one, that is called a single interface. Second one is reconfiguration is difficult. Second one is third one is reconfiguration is difficult. Now, what is reconfiguration is difficult? Reconfiguration means you are having one running network, you are having everything. In this one, you are adding something new. You are adding some new PC. You are adding some new perspective. You are adding some new machine. In that way, that is the reconfiguration of the new machine will generally disturb this whole network, will generally disturb this whole architecture, will generally disturb this whole thing. That is what the thing says. That is what the reconfiguration is called about. Right. So when we are adding something new over here, it will generally difficult. It will generally create the problem. In the same way, if I say if any kind of the problem occur in the route of, that is a predefined route of a railway, any kind of the fault occur in that, what they do, they divert. Although we cannot divert the things, but they divert, and while they divert, it creates the problem for the passengers. Or if they are doing the reconstructions, they are reconstructing their stations, they generally in the main base they cancel the train that we faced our in our daily life in this whole year, in this 2023. Apart from the November, we struggle this thing a lot कि our train got cancelled. Why? Because the reformations of the train stations are going on. The trains, the stations are under the construction. That means they are getting reconfigured, they are getting renovated in whole state. That is the difficult point of reaching the train to the location. That is what the reconfiguration is difficult over here. So this is the whole scenario of the bus topology. Now might be you are having the problem ki where these bus topologies are used. So bus topologies are not used everywhere due to this such kind of the advantage and disadvantage. It is rarely used when we are looking for the broadcasting segment, where we are looking for the one input to the output, one input multiple output, just like in the marriage ceremony or in the some kind of rallies. You have seen ki you are having one video camera in front of the people, and they are giving you the multiple output to the TV channels or the multiple output to their LCD screen. There we use the bus topology. That is actually the connection they form, broadcasting of the statement, broadcasting of the things, where the single line the things goes. That is what the bus topologies are used over there. Is the thing, right? Now, what is the next topology we have? The next topology we have in our hand is about the ring topology, is about the ring topology. Now, what is ring topology says? So ring topology says the ring topology is like a bus topology, but with connected ends, right? The node that receives the message from the previous computer will retransmit to the next node. The data flow is unidirectional, means one direction in clockwise manner. The data will always in a continuous loop, known as endless loop. It has no termination, ends, that is each node is connected to the other node having no termination point. Okay, having no termination point. Now, what does this mean? What these all the things states? What this thing all the things states? So this is a theory we have written over here. Let's understand this thing in the more practical way. Ki what this thing says, right? Because writing all the things, studying with all those statements generally creates the problem. Ki what this thing actually says, what you are saying about this thing. Now, over here. I hope this picture is quite good for you. Okay. Now, let me form one diagram. Let me form one diagram. Here's the thing. For the exact one. Now, the ring topology says, suppose these are the computer systems we have. Okay. Now, the ring topology says, ki I am a kind of the bus topology, but with the connected ends. But with the connected ends, if I just come up over here with this picture, if I connect this end or this starting end together, then it is going to form a structure like a ring. Okay, so over here the ring might be you are thinking like in the circular set. No, not in the circular. The ring always is in the form of closed. The ring is always is in the form of closed. It is not open at any point. It is not open at any point. The ring means close. It can be in the rectangular, circle, any kind of the shape, any kind of the shape and size. So over here, if I say if I connect with this start point to the end point together, then it is going to form a ring topology. It is going to form a closed structure. Absolutely. So the same as with the start topology, same as with the bus topology, we have that they are connected with the closed structure using the single cable, just like a bus topology. But over here, we are not having connected ends. Okay, I hope this point is clear. Now, with this statement, what we have, although we are following the bus topologies, we all the things are connected within a single cable in the single term. The each and every node is the neighbor of everyone. How? The node number one is the neighbor of node number two. Again, node number two is the neighbor of node number three. Node number 3 is the neighbor of node number 4, and node number 4 is the again neighbor of node number 1. Each and every PC, each and every node is the neighbor of each and every one. In this state, whatever the message will be sent by the sending node and the message is being received by the receiving node will always transmit that message to their neighbor node automatically without any kind of the prompt message. In this state, in this state, the flow of the message is always going to be the unidirectional, means in only one direction in a clockwise manner. One direction, clockwise manner. Okay. So with these two statement, if I say node number one is sending the message to the node number two. Now my node number two is the receiving node. What it will do? According to the statement, it will retransmit the data to the node number three without any kind of the problem, without any kind of the knowledge, without any kind of the problem. Although same data is transferred to the node number 3. Again, now who is receiving node? Node number 3. So what will happen? Again node number 3 will send the data to node number 4. Now that data is again on node number 4. Again my receiving node is node number 4. What it will do? It will again retransmit the data to the node number 1. Now again over here my node number 1 is receiving node, so again it will retransmit the data to the node number 2, again 3, again 4, again 1, again 2, again 3, again 4, again 1. So this structure will be goes continuously. This structure will is not going to end, because in this topology the data doesn't know where to end, where to terminate themselves, what is their exact location, that doesn't know. Here we are not terminating the data, we are not having any kind of the form, we are not having any kind of the structure that is shows over here in this example as well, in this diagram as well. So over here what we are having, we are having the complete, like no any kind of the termination point. So here the data is be in their continuous loop from starting to again the starting point, that is the loop. Okay, so it will be in the continuous form, it will be in the continuous form. The reason it is not having termination point. Now with this state, what the advantages we are having, the advantages we are having with these states, if we say, if we discuss about the advantages, we are having network management. Now what is network management? The network management refers to, yes, my network will be managed ki, what the my multiple segments, my multiple team members are working on a different, on a same project, and I want to send the one in, like output to the everyone ki what the single phase we are working on, this thing will work. We can send the establish them theme in the net, in the ring topology, just like the way, just like the way uh, just like if I say you are having a broadcasting kind of the message where you need to type it manually ki what you have done, what you haven't done, or if I just automate this term ki if any update happen it will go to the dedicated person automatically. That is what the network management ring topology forms. Like you are in the circular format, you are just sitting at one point. Okay, you are just sitting with the group of people where whatever you speak it will goes to the everyone, every single point without any kind of the point. That is called as a network management, that is called as a management of the thing. Okay, it also help us in testing our devices, whatever the device we form that is new, that is like in the very new form, that need to be managed. We can also test it over here. Testing in the state कि my device is able to handle the load or not, my device is able to route the traffics or not, my device is able to go with that thing or not. That can be done over here as well. Cost, the cost is same as it is we are having the bus topology, so it is not uh, far from the bus topology, but there's slightly difference over here. Reliability, the reliability over here refers, the reliability over here refers about the related to the data, related to the data it talks about the reliability, the data, how our data is traveling, how our data is forming, how our data is going. That is what the thing is over here, that is what we are doing, right? That is what the thing goes. So reliability, my data is not going out from here, my data is not going anywhere else, it is within this topology only, it is between this structure only, it is not going out from this thing anywhere. That is why it says my data is reliable, my data is with me, right? So these are the few advantages. If I talk about the disadvantages, If I talk about the disadvantages, what are the disadvantages we are having? Difficult in troubleshooting, difficult in troubleshooting, failure, reconfiguration is difficult, delay. Now, let's understand this all the things over here. Difficult in troubleshooting, failure. So over here, if I say ki we all are connected within a single structure by using the single cable, right? Now, if I encounter with the problem over here, if I encounter with the problem over here, if I encounter with the problem over here, then suppose I encounter with the problem, I encounter with the problem. What is going to happen? If I encounter with this problem over here, all the network depend upon each other, so my whole network will be in the off state. So means I will run into the failure. And if my whole network is in the off state, then it is quite difficult for me to find it out from where I encounter with the problem, from where the problem is actually rising. That is what the difficult in troubleshooting. Again the same state. Again the same state belongs to the bus topology we are having. The failure we are having. This is what it says. If I say the reconfiguration is difficult, the reconfiguration, attaching the new device. Suppose I'm attaching the new device over here. I'm attaching the new device over here in this pattern. I need to cut the cable. As soon as I cut the cable, again it will disturb my network. Again it is going to form a failure state. Difficult for me. I can't add any kind of the extra device over here. I can't go with the expansion of my network in this ring topology. That is what it says. Again the delay. What is the delay? Delay happens कि my data is moving, same data is moving on the every direction. So whatever the new update will always reach to the last. Whatever the new update you are having, it will always reach to the recent node at the last one, and the time will come where you will encounter with the network jamming state, where we will encounter with the network jamming state, and the network jamming will again lead towards the failure of the network. So in this whole topology, we are only experiencing the failure. So this is also a least used topology in this IT term. Okay, this is what it says. I hope this ring topology is understood by everyone. So the main concept of the ring topology is that the main concept we have discussed over here in the bus topology ki all the network are going to be formed in the single cable. In that way, the ring topology also says ki all the connection nodes are need to be connected within a closed structure. Doesn't matter what the thing is. If they are in the closed structure, that is going to form a ring topology. Okay. Closed structure means the ring topology, and all the data will flow in the one direction, that is clockwise. That's it. That is the main concept of ring topology that we have. Now, after this, what we have? After this one, which topology we have? After this, we discussed, we keep the few, we go thoroughly about the ring topology, we go thoroughly about the bus topology. After that, we come up with the one more topology that called as a star topology, that changed the environment, that changed the connection view. What? The star topology. What the star topology says? Now, let me write down its definition. Okay, these are mostly used type of topology. It is, let me make the correction, this is the mostly used type of topology in the network implementation. Okay, this is what it says. Now the star topology we have, the star topology. So in this star topology, what we have, in this star topology, what we have in this star topology, the thing says ki whatever the arrangement of the network, like whatever the arrangement of the stations nodes we are having, that all the things are going to connect with one central computer. That central computer can be your server. That central computer can be your server. So what the thing says over here, this one is the thing is over here. This is the statement that we have. This is a statement that we have over here. This is what the start topology actually says. Ki over here you are having the one central point. From one central point, all the nodes are going to connect. One central point means if we all use in this. If we go for studying this one, the most famous example is of library. The most famous example, you will find it everywhere. Those who discuss about the topology and they are discussing about the star topology, they will definitely touch about the library statement. Now what is the library statement says? The librarian who is in this between, who is just sitting in the center of the library, he knows ki where the books are placed, which books are going to find at which point. He knows. If you go and ask, tell me that kind of the manifestation book, that tell me that kind of networking book, he will generally guide you, go to the shelf number 13, you will find it, and exactly you are going to find it over there as well. What is that? He is a central one. Central of what? Of all the connection nodes. In that meanwhile, in that same term, we are having ki all the nodes are going to connect with central term. In this star topology, we are having only one statement. The statement is ki it doesn't matter whatever the number of nodes you have. That doesn't care at all. The care is ki that network are connected with the hub or not. Hub means one central point. Okay, and that central point is going to be your server. That is called as star topology. In the different perspective, it is called as a domain architecture as well. It is called as client server model as well. It is called as domain environment as well. In that whole term, we are having this structure, and this is the mostly used types of the topology that's used everywhere inside every corporates. If you go work, you will find each and every corporate system or devices they are using, they belong to the one network, that belong to the one server. That is what the thing says. That is what the star topology says. In this star topology, the broadcast never happens. In this star topology, the broadcast never happens. Whatever the user is sending the data to them, that will be sent it to them only. It never broadcasts. If I draw the diagram over here, the diagram is going to form like this. This one device, I'm having the four PCs over here. I'm going to have this four PCs over here. Right. This is what the thing is going to be. This is how the things will be. This is how the things are. These all are connected with one central point. These all the things are connected with one central term. So whatever the data is being sent by these people to between them, this will be between both of them only. It is not going to broadcast at any point. And we all know कि for server, so server with the physical connectivity, I can connect two or more, two, five, six computers. But what if I want to connect the 8, I want to connect the 16, I want to connect 32? Then I connect one device called as switch. Then I use the device called hub, that is actual connected with the server. And with that switch and hub, we all know the switch and hub is having the large number of connection capacity that they can connect the number of nodes together. Over here in this topology, the nodes, over here this topology, the nodes are called as what? Clients. The nodes are called as clients over here. These are the client. This is the things. So that is why it is also named as client server model or architecture, domain environment, domain architecture. This is also called as. In the same context, if I ask about advantages, so we are having the good number of advantages over here. Advantages that we have. Advantages we are having efficient troubleshooting. We are having network control. We are having cost effective. We are having easy expandable. We are having high data speed. These are things we have. Efficient troubleshooting. I encounter with problem over here. I encounter with problem over here. So in this topology I encounter with problem over here. So only this portion is getting my damage. This portion will not work. It is not going to affect my any set of the environment. Okay, I am having the problem over here. It means I am going to have the problem over here only. It is not going to damage my any set of the network. It is not going to damage my whole network connectivity. So with that state, with this term, I can easily troubleshoot where I encounter with the problem, how the things goes and how the thing is going to work. I can easily troubleshoot this one. I can easily find it out at which point my network happen, at which point I encounter with the problem, at which point the problem rises. I can easily encounter with that. That is what the efficient troubleshooting. Network control. All the things are going to managed via one central server. So obviously I can manage how many numbers are going to connect, how the connection needs to be managed, what you can access, what you cannot access, what the thing can be goes. That is the network control. Cost effective. So in the general time, like in the we could talk about real in the real term, if I talk, it will generally cost you little bit higher than the bus and the ring, little bit. But nowadays it is going to cost you even the cheaper than that as well, because we are having the cloud technology. Just deploy your server over the cloud, do the things on the premise, problem solved. So it is actually is going to be very cheap as compared to the bus and the star as well, because it is a very in nowadays the things are evolving over the cloud. So that is what it is. Easily expandable. You can edit the devices as easy as taking the biscuit from a packet or keeping your lunchbox inside your bag. This is as easy plug in your laptop in the charge. That is how easy connecting the devices with the this topology. That is why easily expandable. You can expand it very easily. The things depend upon the device, the number of bus, the number of switch that we are having. That in switch, my switch is only capable for connection of 32 devices. So I can't go on the 33, right? I can't go on 33. I can be on 32 only. So for 33, I need to replace that device. So that is the common one. But the connection is very easy over here. High data speed. The data speed is very high. You are having the one central point who is managing everything. So while it is managing everything, you can define, you can say, you can fix it. Ki every point need to, like every device, how much data you want to send, how much speed they require. That is the reason we all say ki the corporate networks, the working network is very fresh. We can download the 1 GB, 2 GB, 5 GB of data in a very easy way. Why? They form the network in the way they form. And what is the forming of network? What they follow? This set of the topology. That is all the things is. Right? Now, it is having the very good number of advantage. Also, it is having the some disadvantages. So disadvantages is disadvantages what it having. Central point failure. Central point failure. Cable. Now, the central point failure says ki if my server is failed, if my server got encounter with any set of the problem. It means I will run into the problem. It means my whole network is failed. Yes, obviously, all the things are managed by a one central term. If one central thing goes, it means whole connectivity goes. It means completely loss. The cable says over here, the use of the cable need to be very precise. The use of the cable need to be very in a very more scientific way. The reason is that you can't use the different set of the cable at every different set of connection. Means somewhere I'm using cat 5, somewhere I'm using cat 2 cable, not acceptable. If you're using the cat 5 cable, you need to use the cat 5 cable everywhere. That is what the cable says. Here the connections of the cable are formed, and we all know the concept of UTP stands for unshielded twisted pair cable. If it is working, it will work. If it goes down, you can't fix it. You need to replace the whole cable. So that is also the point that covers here in the disadvantage, and this is also the thing. Okay. So this is the whole concept about the star topology. I hope this is also understood by you. Correct? Again, what is the next topology we are having? The next topology we are having is our tree topology. The next topology we are having is our tree topology. Now, what this tree topology says? What do you mean by the tree topology? So the tree topology. The name explains tree. Tree. We all know, right? So let me write down its definition. Okay, this is the definition of the tree topology, right? So it combines the characteristics of the bus and star topology. Characteristics. What is the characteristics of bus? Ki all the connections are going to be with the one single cable. And what is the characteristic of a star? Ki all the nodes are going to connect with one central point. These are the characteristics of these two topologies. Okay. A tree topology is a type of a structure in which all the computers are connected with each other in the hierarchical form. There is only one path exists between the two nodes for the data transmission, thus it forms a parent-child hierarchy. Exactly. How? Let me show you. Here you can see it is forming a parent-child hierarchy. If I show you, here this is a tree topology. What this thing is going? This thing is forming a parent-child hierarchy. Over here. This parent-child hierarchy is in front of you. This is the most used topology in the landlines. Most used topology in the landlines. Right now, the Wi-Fi signals that we use at our home, that Wi-Fi that uses this tree topology. Here you can see the device number one is the most connection node, that is called as a one root node, and the rest are known as a child node. The starting point, this node, what this node is called as root node. This thing is called as a root node, and the rest are called as child node. This is what the thing is having over here. Now, Over here, if I say ki in this all the device, in this all the term, in this topology is forming a parent child to root child hierarchy, or a root, or we say parent, root, or we call this parent. So via one input you are having the two nodes where the output can be delivered. Okay, so this is the hierarchy, this is the topology which help us in defining the structure point, defining the connection point, defining the which point need to be accessed what thing. That is what the thing. So over here, this is the most used topology in the landline connectivity, where you all have seen a blue color box, or a connection box where the things get connected, where the uh, straight connections of the things, right? So just a second, huh? Let me come up with that image. Just a second. Okay, over here. I think this image is over here. I got the image. So the image is over here. Okay. So I think that you all know about this image, right? You all know about this set of the image. You all you all have seen this image, right? So in this image, what we have, in this image, what we are seeing, this kind of the box where all the connections are made. So this is actual the one node from where the connection got spreaded towards our house. And when our house goes, at that point we see ki there is a one pole where they install one white colored device. From there they connect one landline connectivity, and from the landline we used to make the call. So this is actual the hub that is used over here, from device 2 or device 3 we can say. And these are the users they are using over here. Getting my point what I'm trying to explain? So in this term we call the parent child hierarchy. So over here, in this topology, you cannot go the direct connectivity. You cannot establish the direct connectivity. No, you just cannot connect yourself to the direct one. No, you need to establish at least two minimum connection from the root to the child, from the root to the user. If I'm the user, I want to use the Wi-Fi in my connectivity zone, in my connectivity path. There might be the at least two minimum number of nodes present to deliver me the connection. Just as if you have seen this thing, you have taken the Wi-Fi connection. If your neighbor is also taking the Wi-Fi connection, whether they are taking from the same company, that company people will again go to the that pole section. That from pole they will again form a new cable and they will give them the connection. They can't use your segment of the cable to give them the connection. No, not at all. That is what the tree topology explains. Ki everywhere the connection will be in the separate state. One node, one central point from where the connections will be gas flows. You cannot rely on each other. You cannot depend upon each other. You need to go with the separate connection from one central point. That is how the tree works. This is how the tree looks. All the leaves of the tree are connected from one central segment. One, they are having one branch from where the things are getting connected. This is what the tree topology says over here. The data transmission will happen by using this cable only. The input, the output, both the things will depend on this cable. Here I cannot draw, I cannot come up with one more cable. I cannot come up with one more cable. No, this is not acceptable. Why? Because this follow the characteristic of star. So by tree, but characteristics of the bus, over by using this picture, by using this thing, you can say, you can find it out. Over here, yes, it is following the characteristic of the star. It is following the characteristic of bus, because for every connection I'm using only one cable, and on that cable only the data sending and receiving is happening. There is nothing as such what the extra thing we are using over here. Not at all. This is how the things work. This is what the tree topology says. This is how the landline uses over here. If I give you the advantages, the advantages is easily expandable. The thing is easily manageable. The thing is error detection. The thing is point to point wiring. The thing is support broadband connection. These are the advantages we have. These are the things we have over here. These are the advantages. Easily expandable. You can add the new device, new connection over here at any point. That is not going to create any set of the problem. That is not going to create any set of the problem. Just as you want to connect, you want connection, you call the customer care, I want the Wi-Fi connection at my house. They will come, they will do the connection, they will go. That is very easy. Just how we connect in the star. Easily manageable. The management is very easy. So it gives you the clarification key, which pack is being used by the which customer and what kind of the connection speed they need to go give. That actually help in defining that kind of segment over here. So error detection. The error detection is very easy over here. Ki if my device number 5 got the problem, my device number 5 encounter with the problem. Okay, it's good. It's quite clear. Ki device number 5 is not working. Rest all the things are working. How? Error detection is easy because you only the person who call the customer care can look, I am not having the connection problem. So error is detected easily. That is what the error detection says. Okay. Point to point wiring, in my explanation I says it will use at least the two minimum connection point. That is the thing. Point to point wiring, I can't go in the direct connections, I can't go at the direct connections of the working. No, I need the connection point, I need to establish the connectivity in the multiple points, then only I'll be able to use the connectivity. So with this one, if I give you the one more, so example is ki, Wi-Fi connection. So some of the areas are still in India, they are not having the Wi-Fi connectivity. Every time you call the customer care, they will say, sorry sir, the connectivity is not reached towards your house or in your area, so we can't give you. So that is the thing. That are the some kind of that says the point to point wiring needed. Support broadband connection. My explanation got started from the landline connectivity by showing you this picture. So this is what the broadband connection says. If I come up with the disadvantages, let me go to the another sheet, or I can use it. Oh, no, let me go to the sheet. Yes. If I give you the disadvantages, so disadvantages is high cost. Disadvantages is failure. Disadvantages is reconfiguration is difficult. Disadvantages is difficult in troubleshooting. Right? These are the things. Now you might be seeing, you might be achieving, okay, high costing. So the high costing, yes, it creates how the companies know ki if I implement this cost, if I implement this thing, I'm going to cost, this is going to cost me higher. The reason behind that is ki they only implemented this connection, Wi-Fi connection in those area from where they can recover the cost, from where they can get the things. They never give you the connection in those area from where they can't uh, get the things. If you call them and they will say ki you are not having the connection in your area, the another line will be कि just you pay us extra, we will do the connection for you. Pay us extra, we will do the connection for you. Why pay extra? Why the things? They know the implementation of this thing, the things are working on this one, it will cost me higher. Okay, the failure chances is high. If your root node, if your upper node is not working, it means the thing will not work. Just like in the parent child hierarchy, if the upper one is not working, the rest one, bottom one will also not work. That is a failure. Here we are having reconfiguration is difficult. Now you will be saying reconfiguration is difficult, but sir, in your explanation you says easily expandable. Now you are saying is reconfiguration is difficult. Yes. How? The thing is, the connectivity of the user for making the user connection is easy, but connection at this point is difficult because the things is going to be formed at here only, not at user end. So that is what it's saying ki reconfiguration is difficult at this box. The reason is ki at this box, if the connection is not made properly, it can lead towards the connection diversion. It will not give you the failure, it will give the connection diversion. In the connection diversion, we have seen ki we are calling to the electricity board, our call is getting to the someone's else house. That is the reconfiguration in the problem. That is what we have seen a lot, and we also taken the advantages. We also cracked the joke on this as well a lot, right? That is the thing. So over here, this thing, if the connection is not made properly over here, it means the problem will rise over here. So that is what it's saying, reconfiguration is difficult. Now, the last disadvantage says over here is difficult in troubleshooting, but again the prophet says error detection. Yes, the detection of the error is easy, but troubleshooting is difficult. How? We detected device number 5 is not working. We says at the connection, device number 5 is not having the connection. Okay, you find it out. But why device number 5 is not having? Might be the problem is with cable, might be the problem is with device number 2, or might be the problem with this device number 221, the cable. The problem can be at any point. So in the year of 2011 or a 10, if a 10 or 11 if I talk, it takes weeks to get resolved. It takes weeks to get resolved. You all have seen ki sometimes you find it out that your telephone is dead. What is it dead? The problem rises, the things are getting resolved. In that same way, the things happens over here as well. Now, nowadays it takes 5 hours minimum troubleshooting hour of tree topology is 5 hour over the user level, in our real area, in our real town. If at the device number 5 the problem is over here, if in that particular section till over here to here, if the thing is defined, problem is resolved, then it's good, it can be resolved as minimum time. But if it is going saying that the problem is from the upper head, it will take time. It will take time, and the minimum time for solving the tree topologies problem is 5 hours. Is 5 hours over here. So this is all about the tree topology. Okay, I hope this thing is also understood by everyone. Now, what is the next topology we have? The next topology we have is our mesh topology. The next topology we have is mesh topology. Now, this mesh topology, okay, let me write down the definition. Okay, this is what the mesh topology is. Mesh topology. The mesh topology is an arrangement of the network in which computers are interconnected with each other through the various redundant connections. Okay, they are the multiple paths from one to another computer. Let me show you the visuals over here. This one. This is your mesh topology. This is your mesh topology over here. Now, in this mesh topology, what we are having? In this mesh topology, node number 1, 2, 3, 4, these all the nodes are connected with each other separately. They are independent to perform. They can establish the connectivity with any node at any point. If I say, if I say, you want to call your friend, you want to call your friend, and you are not having a number. So you have to depend on another person to give you number, and then you will establish the call. That is the one way. Or if I say you are calling to your you are calling to your friend and you are having the number, so that will be quite easy, and you can connect with him at any point from anywhere, from any segment. You can talk with them anything. That is what the mesh topology says. The mesh topology says over here ki whatever the number of nodes you are going to have, that doesn't matter. All the number of nodes are going to connect with each other in the separate form. In the separate form. So whatever the cell phone tower you see in your surroundings, whatever the cell phone tower you are seeing in your surrounding, that all are connected by using this set of the mesh topology. That all the things are connected within this mesh topology. This is a topology where we use the wireless and the wired networks. So that is the reason at the first, when I was discussing about the logical, I use the mesh topology. Why? Ki when we are going for the wireless connectivity, so wireless connectivity means without the thing of wired. So over here, all the nodes are going to connect in this separate way. All the nodes are going to be in the separate connections. You are getting the wireless cell phone network. It means the Airtel is giving you the one, the Geo is giving you the one. It means all your Geo phones are connected with each other at some another point. You are connected with that cell phone network. They all are connected with that cell phone network. That same. If I'm using Geo, I'm using Airtel. So Airtel is not going to give me the separate connection for me. They are having those connections from where I'm getting the signal. That is what the mesh topology says. That is what the thing says. So it is the topology which is widely used for the wireless and the wide network, and this is a topology where wide area network implementation is done. So this topology, all your globe, all over the globe, is connected by using the WAN network. You have seen, you might have this news appear. Geo is doing the underground water cabling under the sea, right? What is that? So they are forming the WAN network. They are over the WAN network. Our each and every network, we are our all the data centers from all over the world. They all are connected over the mesh topology. Here, I don't need to depend on anyone. I don't need to depend on any other nodes. If I want to establish the connectivity from node 2 to node 3, I can. If I want to go from node 2 to node 4, I can. It is a unidirectional connection. It is a unidirectional. That is what the thing says. This is how the things work. The mesh never works on the dependent state. It works on independent state. This is what the thing says. If I talk about its advantages, advantages is very easy. Reliable, fast connection, so communication, easier reconfiguration. Yes, these are the advantages. Reliable of the what data. So whenever you call to to your friend, so when you call to a friend, so it goes broadcast to everyone. No, the talk between you and your friend is between you, both of you only. It is not going to go with anyone else. Okay, that is what the reliable. Although all the connections, although all the things are connected with each other, but they are having the some set of reliability. Ki whatever the data is between both of you, it will be between both of you. It is not going to spread it out anywhere. That is what the reliable is. Fast communication, as I said, the connection is very easy. When I don't need to depend on anyone, I need to go at any phase. I can connect with anyone on my own basis. So obviously the connection is going to be fast. As see, you just press the call button, the call goes placed. That is what the fast communication. You turn on the data, you are using the surf. You don't need to depend on anyone. You don't need to depend on someone to turn on the hotspot. You are having your own thing. That is what the fast communication says. Easier reconfiguration. Nowadays, if I give you the live example is कि some areas are over the 5G connection, some areas are still on the 4G connection. If you are having the 5G phone, you go, your connection automatically turns out to the 5G. It never asks. It will never ask what. I am shifting from 4G to 5G. Can I? No. It will shift. You travel the world. You travel whole India. You travel from one location to another location. Is ever phone give you the prompt कि I'm shifting from one network to the another? हाँ, they will give you the message कि welcome to this network. You are connected in this network. Is your phone asking कि you want to connect with this network or not? No, it will not ask. It will get the connection. It will start connecting. As you are traveling, it will. You are using. You are connected. You are using. You are connecting. You are using. You are connecting. You are going separately. That is the thing. It will never ask. It will never give the prompt. कि you are at this stage. You want to connect. You are at this stage. You want to connect. Not at all. The configuration is very easy. Just taking the device you are connected, just moving you are connected, just connect any two things, very easy. This is what it says. If I talk about its disadvantages, disadvantages: cost, management, efficiency. Now, disadvantages over here is cost. Obviously it is going to cost you very high as compared to all the topology. The mesh topology is the very costly. As compared to the tree as well, it is cost you higher, because in the tree topology somewhere we are connected to the leaf nodes, but over here we are going to connect each and every node with each and every one in the separate way. I am having the five in this picture, the things explained in a very well way. I am having the four node, so all the four nodes are connected, but these all the four nodes are connected with each other in the separate state as well. In the same way, the management is difficult. If I give you the PC, five PCs are connected with each other, and if I say ki manage the data flow, manage the things, so management is difficult over here. If the problem rises, to difficulty in troubleshoot that as well. Efficiency. Efficiency is now having the one term: the large number of connection, the less number of speed. The large number of node, the less number of speed. The less number of node, the large number of speed. We all experience this thing. In the daytime, if we use the internet, so how much speed you get? 1 Mbps, 2 Mbps. If you're downloading, maximum you will go to the 5 Mbps. If you're downloading these segments, if you're downloading these things. And in that same way, if you are using the same network, using the same thing at the midnight, around 1 a.m. or 2 a.m. or 3 a.m. in the morning, you will find the speed is very good. The thing that takes to download 2 hours, it is taking 15 minutes. It is taking 1 hour. It is taking 50 minutes. Why? The connection, the number of connection at that time is very less. At that time, the connection is free. We all say the line is free at that time. What is the meaning? Line. The line means the number of nodes are less at that time. That is what the efficiency says. That is what the efficiency says. Okay. So this is all about the mesh topology. So mesh topology, the live example I have given you, all your cell phone towers are used, and according to that, we use it at many different business. This is what about the mesh topology is over here. I hope again this mesh topology is totally understood by you. Okay. If you are facing any kind of the problem in this whole explanation, you didn't understand what the bus, tree, mesh, hybrid, or whatever the thing is, you can ping it over the comment sections, and we will try to resolve it as soon as possible. Okay. So don't worry, don't feel any kind of the problem, don't feel difficult, or don't make yourself difficult in asking the queries. You are free, ask queries as many as you can. Okay. Now over here, what is the next one we have? The next topology we have is our hybrid topology. This is the last topology that we have, hybrid topology. This is all the hybrid topology. Now, what this hybrid topology says? What this hybrid topology says? So we all know about the meaning of hybrid. We all know about the meaning of hybrid. What is the meaning of hybrid? The hybrid always says the combination of two or more than two different things. When we combine the two or more than two different things, then we call it as a hybrid. Then we call it as a hybrid. So over here, this image which is in front of you, this image says all. Over here you can see we are having the multiple tree topologies. One is ring topologies. We can say it is a star as well. Okay. So over here they all are connected with one ring from here. So the when we combine the two or more than two different sets of topologies together, that is called as a ring hybrid topology. That is nothing as such. Okay, I'm having the two star are connected with the same thing. Two star are connected together. No. Two star, two bus, two ring, they are connected by using the two devices. That is going to call as the same thing. No, not at all. Two different. Two different. Here I am having this one. If I place one switch it over here, if I place one switch over here, and if I again form one more device, suppose I am having one, I place the switch, and with this switch I am having one device is over here, right? I am having one device over here. So what is going to happen? Have a look. I connect this device computer with this one. I am forming one bus over here. So this is the rough diagram I am forming right now. This is a rough diagram which is just to give you the clarification. Yes, what the hybrid topology says. So hybrid topology is not like combining of the two or more than two different topologies. No, here you can see. Here I am having this. This is going to be the star. Here we form one bus. Here we are forming again ring. So what is this? So this is giving you the explanation कि hybrid topology is nothing like that कि combination of two similar topology by using the two different device. No, the combination of two different topologies from 1 to 5, if they are combining together by using the different set of devices, that is called as hybrid topology. Simple statement. So hybrid topology is nothing. The hybrid explains the everything. If you belong to the cloud, if you go with the development, if you go with the networking segment, everywhere you will find it a hybrid. What is the meaning of hybrid? When we combine the two different sets of things together, that is what we are forming, we are doing over here as well. This is what the hybrid topology. That is what the hybrid topology is. If I talk about its advantages, reliable. Advantage is reliable, scalable, flexible, effective. This is what the advantage is. Reliable means whatever the data is going to be, that is going to be in between this topology only. It is not going to out from this one. Scalable. You can add the as many topology, you can remove the as many as topology as you want. It is not going to hamper the any set of connectivity. Flexible. Implement it at any point. It is going to work. Effective. The use of this one, the procedure of this one, the process of this one is as much as capable. It will never let you down in the failure state. It will never take you down in the network failure state. That is what the effective says. This is what the advantages says. If I talk about the disadvantage, so disadvantage over here is never refers towards the failure state. Where it refers? Complex design, costly infrastructure, costly infrastructure. Now, Over here is complex design. Yes, by seeing over here, you can see that the design is going to be very complex. It is very complex. It is very difficult to identify at which point which connection topology we are using, which point we are using. That is what the complex design we have. Costly infrastructure. The costly infrastructure is that everything that we are going to use it, that is your cable, that is your networking devices, that is your whatever the number of nodes that need to be capable enough to handle the load from the multiple devices, from the multiple different topologies at the same time. That is what the infrastructure says. The implementation of this hybrid topology is not as easy, is quite difficult. So it is used by the people those who are having this combination of multiple, just like ISPs. Our ISPs use the hybrid technology because they need to manage their office, they need to manage the broadband connection, they need to manage our cell phone connections. So for the cell phone connection we'll be using MIS. For the broadband connectivity we use tree. For their offices we use a star. So they combine all the topologies together, so to form a separate network. That is what they called as a hybrid topology. So this is what we have it over here. Okay, so this is what about the topology. So with all this explanation for all the things that we have gone, I think it gives you the clarification, it gives you the understanding, yes, what the topology says and how the thing is. So basically you just studied about what the types of the topology is called as, but over here it also includes how we configure this thing. The configuration refers to the architectural way, how we are placing the devices, how the device get placed, how the device is going to be connected now. Over here it gives you the procedure, it gives you the way, it gives you the architecture. That is all about the topology. I hope this video finds you interesting, and or whatever the things I discussed is knowledgeable for you. So thank you so much for watching this video and giving your time. Thank you so much, guys. We are hoping the good comments in the comment section. So please share what are the things you're looking for and also how the video finds you. Okay. Thank you so much. Have a great day. Thank you, guys.